All right, welcome back to part 2 of conversion problems. And so we initially talked about conversions between one unit to another. And now we're going to talk about when these numbers we have, sometimes they're going to have more than one unit to them that we have to change. And so the biggest example that I'm going to talk about is density. And so we'll have another whole lecture on density, but we need to also practice on changing their units. And so what density is, as a brief overview, and like I said, we'll talk about this more in section 3.4, but density is equal to some sort of mass over volume. But as we've learned, mass and volume can have all sorts of different units associated with them. So let's say we want to compare two different densities. Well, if one's in grams per liter and one's in kilograms per milliliter, how are we going to compare them? We can't until we get them both in the same units. And so I'll start with an example here. Let's say I know the density of manganese or something is 7.21 grams centimeters cubed. And then I want to know what is the density in kilograms per meters cubed. Or actually, back up here. I'm going to start off with a little bit of an easier one. We're going to go to grams per liter and kilograms per milliliter. Okay, so now the first thing to recognize is that we are going to be comparing two different sets of relationships between our two units, because our units as a whole are grams per liter or kilograms per mil, but we're going to have to change between grams and kilograms here. And then we're also going to have to look at the relationship between liters and milliliters. So let's first start by defining those two relationships. And so I'll put I'll do it this way. I'll put spots up here that we can fill in these relationships. So let's first look at grams to kilograms. So grams would be at unit, and our kilograms is going to be at this top stair here. So for comparing between grams and kilograms, which one's higher up the staircase? Should have said kilograms, so kilograms gets the 1. Now, we have to figure out our power of 10 for grams, so we count starting with the kilo stair. We go down 1, 2, 3 stairs until we reach grams. So we have 10 to the third grams for every 1 kilogram. Now, if we are comparing liters and milliliters, liters is going to be our unit now. And then we're comparing it to milliliters, which is all the way at the bottom. So I'll set up my little relationship here, and then we'll fill it in. Well, liters is more towards the top, so liters gets the 1. And we're going to have 10 to the power of 1, 2, 3 for mils. So here's our two relationships that we are going to be using for this problem. So now, the next step would be recognizing this 7.21 grams per liters and realizing how to write it. So the way that we are going to write this into a fraction is you'll always write the number and the unit that comes first on the numerator, and whatever you have after that forward slash, you're going to put at the bottom. So we have 7.21 grams per liter. So that is what we know. That's what we're starting with. And so now we know that we have to both change grams to kilograms and change liters to milliliters. Instead of doing both at once, we're going to break it down to one at a time. So let's start with grams. Let's change that to kilograms. So we're using the relationship highlighted in blue, and now we have to set up our conversion factor. So if grams is on the top of our fraction here, where do we want grams in our conversion factor? Hopefully you are said the bottom, because this is where we want grams if we want them to cancel out with each other. That puts kilograms on top. And so now if we fill in with our number values For every 1 kilogram, we have 10 to the third grams. So then grams will cancel out. Now, we need to focus on liters to milliliters. So let's start our next unit conversion. Well, liters is on the bottom of our initial value. That means we're going to want liters on the top, because remember, you want one on the bottom, one on the top for them to cancel, and then that leaves us with milliliters in the bottom. So if we use the relationship highlighted in purple, we have 1 liter for every 10 to the third milliliters. Now now liters on the top is canceling with liters on the bottom here, and we're left in units of kilograms per milliliter, which is what we wanted. So now we just have to do the math. In our case, we are now left with 7.21 at the top divided by 10 to the third times 10 to the third, or 7.21, you can divide it by 10 to the third, get that number, and then divide that by 10 to the third. But 7.21 divided by 10 to the third times 10 to the third is the same thing as 7.21 divided by 10 to the 6th, because when you multiply powers of 10, you can just add their exponents. And remember, the rule is if the power of 10 is in the bottom, that's the same thing as when we multiply it instead of divide it by the negative exponent. So there's lots of different ways you can write the math that we have to do for this problem. And so this last one here is a total valid answer as it's in scientific notation. Otherwise, if you computed out the decimal, you'd get 0.0000721. And then don't forget our units of kilograms per mil. Okay, so those ones are a little tough as they require multiple conversion factors, but it's important to know. And so what I want you to do now after seeing this is I want you to work through the conversion problems that are posted online along with this material. I do want to give one little bit of information. It's an important conversion factor for chemistry, and it will show up on your problems. And that is 1 centimeter cubed is equal to 1 milliliter. And so what this is saying is if we think about a cubic centimeter, so what that represents is the volume of a box, a volume of a cube. Because if each one of these, the volume is equal to, base times width times height, right? That's the equation for volume. If each one of those things are 1 centimeter, so we'd have 1 centimeter times 1 centimeter times 1 centimeter, well, that is just equal to 1 centimeters cubed, right? Because 1 cubed is just 1. And so when we have units of centimeters cubed, we're actually working in units of volume. And so this comparison between milliliters and centimeters is just something that is an important nugget of information to have, because it's not explicitly laid out in the staircase. But this brings up another point I would like to make. Let's say you are asked to go from centimeters cubed to meters cubed. How would you do that? Well, we don't have a defined relationship between cubic centimeters and cubic meters, but we do have a relationship we can find between centimeters and meters. So if I'm going to draw the bottom portion of the staircase here. If this is unit, and then this is deci, this is centi, we are now comparing between this stair and this one here. Well, that's a 1-2 drop. But if meters is higher up, meters gets the 1. And because we have 2 stairs, centimeters is 10 to the 2nd. So now we have a defined relationship. If we want to get it cubic, whatever we do to the unit, we have to do to its value in front. So let's cube both sides And so if we cube a power of 10, you multiply the exponents. And so we get 10 to the 6 centimeters cubed is equal to 1 meter cubed. Because remember, 1 cubed is just 1. So this now is our relationship that we can use for conversions. So understanding that if we start having squared or cubed units, we have to square or cube their conversion values in front of the variable as well.